Characteristics of clear data organization. Appropriate summary statistics are expected to describe any data distribution. So we have the mean and the standard deviation, which are usually reported for normal distributions in an interval or ratio level of measurement, and the median and the semi-interquartile range are used to report the scores if the data is not normally distributed, again for interval and ratio measurements. Appropriate data organization comes before data analysis. So the characteristics of the data distribution and the level of measurement or the specific research design employed determine the type of statistical analysis procedures to be used. The selection of appropriate statistics depends on the level of measurement of the data, the number of observations, and whether the data is normal or skewed. Once the study has been organized, certain statistical procedures can be used to analyze the results. The statistical procedures may be generally classified as, like I said, analysis of relationships or analysis of differences, depending on what you want to look at. The selection and application of data analysis techniques is determined partially by the research question and then the level of the data that's yielded. The analysis techniques may be either correlational or inferential, whether we're looking to analyze relationships or analyze differences. The choice of the analysis procedure also depends on the number of variables being examined, the size and characteristics of the samples used, and the type of research plan in effect. The normal curve model. A construct based on the observation that measures of physical or physiological variables derived from large numbers of people or animals tend to form a characteristic type of distribution when graphed, the normal curve. So it's this bell-shaped normal curve. We have a concentration of values in the middle of the distribution with fewer and fewer values as the extreme scores are approached. So 68% would fall within, 68% of your data or your people would fall within one standard deviation of the mean. So I always think of height, right? So 68% of people would fall either one standard deviation below or one standard deviation above whatever the mean height for women is, 5'4", okay? Then 95% of people will fall within 2 standard deviations of 5'4" women. Then within 3 standard deviations of the mean form basically the entire population of women in terms of height. I'm just using height as an example, I don't know if I'm correct or incorrect, but the point is within 1 standard deviation of the mean, the majority of the population will fall. It's also called the Clausen curve or the normal curve. Like I said, with the normal curve model, about 2/3 of cases fall within plus or minus 1 standard deviation of the mean. The extent to which the data that you collect resembles the model determines the usefulness of the model, or basically what statistics you can use. If you fall in with that normal curve model, you can use parametric statistics. If you don't fall in with the normal curve model, you have to use non-parametric statistics.